In a world flooded with AI-generated images, telling real from fake is getting harder every day. But what if the secret to building a better deepfake detector wasn't some radical new invention, but simply finding the perfect recipe of existing techniques? Welcome back to Summarize Science, where we break down the research that's shaping our future. Today, we're looking at a paper called Generalized Design Choices for Deepfake Detectors. Think of building an AI detector like baking a cake. For years, researchers have been publishing new recipes, but it's been impossible to tell if one cake is better because of a new ingredient or just because it was baked at a different temperature. This paper tackles that problem by running a massive experiment to test every single step of the process. As you can see in this diagram, they isolated and tested all the different design choices that go into building a detector. This includes things like how to prepare the training images, how long to train the model, and whether to have the AI look at the whole picture or just small pieces. One of their most interesting discoveries was about how to prepare the training images. They found that the best approach wasn't just random blurring or distortion. Instead, the most effective strategy was to mimic what actually happens to images online, repeatedly saving them as JPEGs, which slowly degrades the quality. By training the AI on images that have been roughed up in this realistic way, it becomes much better at spotting fakes out in the real world. Another huge challenge is keeping detectors up to date. When a new AI image generator is released, how do you teach an old detector about it without making it forget all the previous ones? Retraining from scratch on every single image, both old and new, is incredibly slow and expensive. The researchers tested a method called harmonic replay. This smart strategy involves retraining the detector on all the new images, plus a small, shrinking sample of images from the older generators. This acts like a refresher course, and as these graphs show, it works almost as well as full retraining, but is dramatically faster and more efficient. You might also think that teaching a detector to identify the exact AI model that made an image would make it smarter. But surprisingly, the study found it's generally more effective to just focus the detector on the simple, binary question of is this real or fake? Over-specializing can sometimes hurt its ability to generalize to brand new generators it's never seen before. So after all these tests, the team took all the winning ingredients they found. They combined the best data preparation, the ideal training time, and the most effective input strategy. The result was a configuration that set a new state-of-the-art performance on a major deepfake detection benchmark. So, what's the big takeaway from all this? The research provides a clear, tested blueprint for building better, more robust deepfake detectors. The key is to train them for the real world by simulating internet degradation and to update them efficiently using smart replay techniques so they don't forget the past. This work doesn't give us a single magic bullet, but something far more valuable, a reliable recipe book. It's a foundational step towards creating the tools we'll need to maintain trust and fight disinformation in the rapidly evolving age of AI. Thanks for watching Summarize Science.